So in this video, we're going to talk about a practical application for use of the ideal gas law, PV equals nRT. Practical application in helping to determine the identity of an unknown gas. And specifically, we're going to use the ideal gas law to determine an unknown gas through the gas's molar mass. So if you remember, molar mass is grams divided by moles. Hey, we can use the ideal gas law to find moles because PV equals nRT. So that's a way we can find moles. So given the appropriate information, we can use the ideal gas law to find the molar mass of a gas. And then we can look at our handy dandy periodic table to determine what the identity of that gas is. So let's go ahead and talk through this example. So let's say we have a sample of a noble gas. So if you remember, noble gases, those are guys in group 8, has a mass of 0.136 grams. So actually, we're halfway there already with this problem. I already gave you the mass. We just need to know what the moles are. That's where the meat of this problem will come into play. We have the volume, the temperature, and the pressure of that particular gas. And I want to know what its molar mass is and then determine the identity of that gas. So to find the molar mass, we've already got the grams. We need to find the moles. So we find moles by using PV equals nRT, solving for n, number of moles, by dividing both sides by RT, then putting in our pressure, volume, and temperature measurements along with the units. You see the units cancel. And so doing that calculation, we get an appropriate moles of gas. And then we use the moles in calculation of our molar mass along with the 0.136 grams that was given to us in the problem. When dividing those two, we then have the molar mass of our gas. And then you can go to the periodic table, and then you can look to see which noble gas has a molar mass that is closest to 28. So let's do another practice problem. Let's say we have an elemental diatomic gaseous sample. This diatomic is going to be important shortly. You'll see later. We have an elemental diatomic gaseous sample. We have a mass. We have a volume, a pressure, and a temperature. What is the gas? So I've got that same question written up here. So I went ahead and solved for the moles of gas because I'm going to determine the identity again by its molar mass. I already know the grams. I'm going to use PV equals nRT to solve. So putting in my appropriate values of pressure, volume, and temperature. This is what I come up with, and then you can see, as soon as I get my pointer here, then you can see the units canceling. So you are left with moles. Doing that division and multiplication, you should get 7.40 times 10 to the negative 3. So now we can determine the molar mass of that gas by taking the grams, which was given to us up here, divided by the moles. And that gives us a molar mass of the gas of 70.9 grams per mole. Now you may be going and looking at your periodic table and thinking, I don't see anything on there that's close to 70.9 grams per mole. That would be a gas. Here is where this diatomic comes into play. If this elemental gas is diatomic, that means that the molar mass needs to be divided by 2. So when you do that, that gives you the molar mass for each element in that gas. Now you can look at your periodic table and say, which element is closest to 35.45? Oh, that's going to be chlorine. So our unknown gas is going to be Cl2. And when you calculate the molar mass of Cl2, you should get 70.9 grams per mole. So you should feel comfortable being able to use PV equals nRT to find moles of gas, to find N, and then given a mass, be able to find the molar mass of that gas. So in the next video, we're going to talk about how to use PV equals nRT to find the density of a gas.